Let's dive right in. Look, we hear constantly about the incredible promise of artificial intelligence, right? How it's going to revolutionize climate modeling, totally optimize our energy grids, and basically map out a sustainable future for us. And yeah, it is a hugely powerful tool. But today, in this explainer, we need to have a serious conversation about the hidden physical costs of all that technology. Because while AI might help us figure out a path forward, the massive infrastructure actually powering it is aggressively expanding our carbon footprint. And as those emissions keep rising, we are pushing dangerously close to some massive climate tipping points. These are the kinds of thresholds that are forcing scientists and, frankly, global policymakers to start considering some incredibly controversial emergency brakes. So here's our roadmap for this briefing. We'll start with the climate tech paradox, move straight into those looming tipping points we're approaching, and then we're going to unpack the high-stakes geoengineering emergency brake. After that, we'll look at the geopolitics of a literal sunshield before wrapping up with the sustainable infrastructure we need to be building right now. All right, part one, the climate tech paradox, digital promise versus physical cost. Okay, we really need to completely shatter this whole myth that the digital cloud is just some magical, weightless thing floating in the sky. It's really not. We've got the slick software and these ambitious corporate net zero pledges on one side, but the physical reality? It's massive, sprawling warehouse data centers. To put this physical strain into perspective, some of these data centers literally guzzle as much water in a single day for cooling as an entire small city. We are talking about staggering electricity demands and just literal tons of electronic waste from constant, relentless hardware upgrades. It's a huge, tangible burden on our local communities. And the scale of this footprint, it's ballooning. Just look at this metric, 3 times. Research shows that U.S. data center carbon emissions roughly tripled, shot up 3 times between 2018 and 2024. That is an absolutely exploding demand for power that makes moving our energy grids away from dirty fossil fuels incredibly difficult. To really grasp what's driving this, check out this gap. A single generative AI prompt uses up to 10 times more electricity than a classic Google search. 10 times! Now, multiply that by the millions and millions of prompts happening every single day, and you quickly see how this relentless demand is completely outstripping our current renewable energy capacity. It's forcing major tech companies into this weird green paradox, where they're quietly having to fall back on fossil fuels, like natural gas, literally just to keep the servers humming 24/7. Which brings us to part 2, looming climate tipping points, the shrinking window. So this exploding physical tech footprint is colliding head-on with our shrinking climate timeline, pushing humanity towards some very severe deadlines that every policymaker out there needs to be acutely aware of. Let's make sure we clearly define what we're facing here. A climate tipping point is a systemic point of no return. Think of it like a giant game of Jenga. You know, you can pull out a few blocks safely, but eventually you pull out just one too many and the whole tower comes crashing down. Once we cross these specific thresholds, the climate damage becomes entirely self-perpetuating, meaning human intervention won't even be able to stop it anymore. Using that Jenga tower analogy, let's look at one of the most dangerous blocks we're messing with, the Arctic. It's warming nearly 4 times faster than the rest of the planet. Here's how the chain reaction works. Step 1. The ancient permafrost melts. Step 2, massive amounts of trapped greenhouse gases, particularly methane, escape into the atmosphere. And step 3, those gases trap way more heat, which just melts even more ice. It triggers this terrifying, unstoppable feedback loop. And the scariest part? This doesn't just happen in a vacuum. It triggers a multi-front international crisis. Beyond the melting permafrost, policymakers really have to prepare for the potential collapse of the AMOC. Those are the major Atlantic Ocean currents that literally regulate our global weather. If that system stalls out, it scrambles global crop cycles and poses a massive threat to our food supply. Add to that the risk of the Amazon rainforest suffering a massive dieback, turning into a dry savanna and releasing decades worth of stored CO2. These are not just niche environmental issues, you guys. They are massive, systemic disruptions to global stability. Moving to part 3, the geoengineering emergency brake, a controversial shield. Because our emissions keep rising and our progress is, frankly, just too slow, scientists are actively studying some extreme, absolute last resort options. And one of the most controversial is called Stratospheric Aerosol Injection, or SAI. The idea is to fly a fleet of high-altitude airplanes and spray tiny sulfur dioxide particles way up into the upper atmosphere. Basically, it creates a massive temporary mirror that bounces a fraction of the sun's light back into space. But I really want to emphasize this. This is strictly a temporary emergency brake, just to buy humanity some time. It is absolutely not a cure for carbon pollution. It doesn't fix things like ocean acidity at all. The wild thing is, we actually have historical proof that the physics behind this work. We can compare the proposed human intervention directly to nature's own sunshield. When Mount Pinatubo erupted back in 1991, it naturally blasted millions of tons of sulfur dioxide into the sky, which is the exact same material proposed for SAI. That natural shield actually lowered global temperatures by about 0.5 degrees Celsius for 15 months. So the cooling effect, it's real. But artificially replicating that natural event comes with immense, potentially catastrophic risk. If we deploy a solar shield but we don't actually clean up our energy grids and reduce the underlying emissions, stopping that shield suddenly could trigger what's called termination shock. This would be a devastating, incredibly rapid rebound in global warming that our ecosystems simply couldn't adapt to fast enough. For any policymaker, this is a literal doomsday scenario if it gets mismanaged. Okay, part 4. Geopolitics of a Sunshield, the governance challenge. All of this leads us to a massive, unprecedented international governance dilemma. It really culminates in the ultimate, high-stakes question for global leaders: who gets to control the Earth's thermostat? Because realistically, this technology is theoretically cheap enough that a single wealthy nation, or maybe even a billionaire-backed rogue organization, could just decide to deploy it without any global consent. What on earth happens then? See, the biggest challenges of geoengineering aren't really technological at all. They're deeply messily political. Deploying a sunshield alters the atmosphere globally, but it creates radically unequal outcomes locally. One country might successfully cool down, right? While a neighboring country suddenly faces a severe drought or finds their vital monsoon seasons completely disrupted. This is a massive international security risk. It absolutely demands unprecedented global agreements before anyone even considers pressing that button. Finally, part 5. Sustainable infrastructure and governance, the actionable path. Because the risks of extreme geoengineering are just so insanely high, we have to pivot back to what we can actually control today, which is mitigating our own technology infrastructure. And before we dive into the best materials for building sustainable data centers, we've got to understand the stark difference in how we handle our waste. Standard recycling is honestly often just downcycling. Materials just degrade into lower quality items that eventually, inevitably, end up as trash anyway. True upcycling, on the other hand, transforms that waste into high-value, durable building materials, permanently locking them into the economic cycle. Think of it as a 3-step ladder of sustainability for the tech industry's physical hardware. Step 1 is good, we use upcycle plastic for construction. Step 2 is better. We use bioplastics made from organic waste, skipping petroleum entirely. But step 3 is the absolute best innovation we have right now: UBQ materials. These guys literally convert completely unsorted household garbage into a climate-positive matrix. Let's look a little closer at this, because it's a real game changer. UBQ actively takes everyday, completely unsorted household garbage. I'm talking everything from banana peels to dirty, greasy cardboard, and it locks it into a reusable plastic-like material. By keeping all of this stuff out of landfills, it actively prevents methane emissions. And it's not just theoretical. It's already replacing oil-based virgin plastics for huge global brands like Mercedes-Benz and PepsiCo. This is exactly how we can radically overhaul the physical hardware of our tech industry. And look, alongside smarter materials, we've got to immediately adopt smarter operations. Take liquid immersion cooling, for example. Instead of using massive cooling towers, you literally submerge the data center computers in a specialized fluid. It safely absorbs massive amounts of heat without evaporating millions of gallons of water. This instantly stops the massive drain on local, often drought-prone, water supplies. So this brings us to the final, critical crossroad. AI is an unbelievable tool for sure, but there is no magic, weightless cloud, only power-hungry buildings right here on Earth. So the question is, will we rigorously account for the true physical footprint of our digital habits today by demanding sustainable infrastructure? Or are we just going to ignore the cost, blow right past those climate tipping points, and force global policymakers into a terrifying high-stakes gamble with planetary engineering tomorrow? The choice is entirely ours. But you guys, the window to make it is closing fast.